Hello, hi everyone. So am I audible, right? Just let me know in the chat section whether I am audible or not. Mm, okay, audible. Okay. So good evening, everyone. So let's just wait for 3 or 4 minutes to let everyone join. My screen is visible, right? So hi everyone. So the screen is visible and I'm audible, so everything is going good. So let's just start. So let me just change the slide. So the topics for the day are what is OpenCV, and we'll be learning hands-on implementation of OpenCV, and then we'll be learning about color spaces, red, green, blue, and HSV, which basically stands for hue saturation. Okay. So and then we'll be coming to image segmentation, edge detection, and then Cascade classifier, and then we'll be using Cascade classifiers for face detection. So basically, what is OpenCV? So OpenCV is a open source computer vision library, and it is very efficient and very optimized library which is implemented in C and C++. So the source code of this library is completely written in C and C++. It contains large number of computer vision, image processing, and general purpose numeric algorithms, and it is a great library if you want to get started with computer vision. It contains huge number of functions for image processing tasks, and one of the best thing what makes OpenCV so popular is its implementation of more than 2,500 algorithms. And one of the one of the other best thing that it's available for complete free for commercial also as well as academic purpose also. So uh, since previous 10 to 20 years, we have seen that there are some job roles related to OpenCV, and they call themselves OpenCV developers. So industry is adapting very quickly to this OpenCV library. And the majority of the tasks which are being performed in industry related to computer vision use OpenCV, and the library has interfaces for multiple languages, which includes Python, Java, and C++. Right now, I'm not sure about Android platform, but somewhere in its documentation, I read that it's also available in for Android also. So just check it out. Okay, guys. So let's just get started with OpenCV. So the best thing about OpenCV obviously is its efficiency because it's written in C and C++. And this is the code, this is the basic framework to read an image using OpenCV. Okay, so here we import a NumPy library, which is a common library, and we should import before performing any functions in Python because all types of array functions are performed using NumPy and PLT for plotting purpose, and then we'll be importing OpenCV. So OpenCV is available as a CV2 Python, CV2 package in Python. Okay, and this is the syntax to read an image. Okay, so you can do, so CV2 contains a function which is known as imread. So what imread basically does is that this function will take image as an input, the path of the image, that is basically this one. It will take path as an input, and after giving the path, the image will be rolled in image form. So one of the most important point to note down over here is that yesterday we discussed about pillow library. Okay, so whenever you open using pillow library, this image function, so this image function contains actual image. Okay, and in terms of OpenCV, this image variable will be containing array, not an image. Okay, so this is the most important point to note it down over here. Also, we will be just exploring this variable in Google Colab, so don't worry about this. And second important thing about imread function is that it reads an image in BGR format. Okay, so this is B for blue, G for green, and R for red. So normally we have images in RGB format. Okay, so normally we have images in RGB format, but OpenCV reads image in BGR format, that is blue, green, and red. So to visualize the image and how it looks like in real world, we convert this BGR to RGB. Okay, so OpenCV reads an image in blue, green, and red format, and then we convert it into red, green, and blue format because that's the standard format, and that's how computer and that's how the images are in real world. Okay, so this is the second most important point about this imread, that it reads images in BGR format and then we convert it to RGB. Okay, so to convert it into RGB format, we use CVT color function, which is provided by CV2. Okay, so CVT color will take image as an input, and here we need to specify then to which format we actually want our image to change it to. Okay, so this is the default format in which OpenCV reads an image, and we'll be using cvt2.color underscore bgr, that's for blue, green, and red, and then to RGB. So this function basically means that we are converting blue, green, red to RGB. Okay, and here are some other functions, or you can say the parameters which are provided in the CVT in this imread. Okay, so there's an option to read the image in default color format, and for that we use cvt.imread underscore color. And if you want to read an image in grayscale format, we used imread underscore grayscale. And if we want to basically, this is a special format. So imread unchanged will load images according to alpha channel. So what is alpha channel? So basically above this blue green channel, or above this blue green channel, OpenCV will automatically add another channel that is known as alpha channel, and this channel will be So the opacity, you can say, or transparency will be controlled using this alpha channel. To use this alpha channel, you need to read image using this cv2.imread underscore unchanged. So that's about how we read, how OpenCV reads an image and what is the default format of reading images. And just let me know in the chat section if you have any doubts or problems. So Tanishka Yagnesh has a doubt. What is the difference between BGR and RGB? Basically, the channels are arranged in blue, green, and red format, and the default image and the image we see is in RGB format. Okay, so there's not much difference. Only the channels I voted. Okay, channels are shuffled in BGR format. So and all the other algorithms such as when you will be applying TensorFlow, you will be coming to know that the images whenever we are performing real world tasks, it accepts images in RGB format. So there it becomes important to convert blue, green, and red to RGB format. And Artham is saying that BGR is blue, green, red, and RGB is red, green, blue. Exactly. That's one. So now let's come to the slide. Yeah. So now it's time for RGB color space and HSV color space. So basically, what is a color space? So color space is a protocol for representing colors in a way that makes them easily reproducible. Okay, so don't get confused with this definition. Okay, so color space is something related to color, and whenever we change this color space, the properties of image, some particular properties of an image are highlighted. Okay, so when you will be playing with color spaces, you will be now coming to know that to basically visualize some particular property of an image, you need different color spaces. Okay, and as I told you yesterday, that grayscale images have single pixel values and color images contains three values. And most of the computer vision cases we use are in RGB format. Okay, and application like video compression and device independent storage, these are heavily dependent on other color spaces. Okay, so there is one more important color space, that is SHSV format. So it stands for hue saturation value. Okay, so why we use this color space? Okay, so we know about RGB color space, that yeah, it's a by default color space, and this is how an image looks like this is how an image looks like in RGB color space. Okay, so why, so now there is like why we use this HSV color space. Okay, so we use this HSV color space to highlight the intensity and color information. Okay, so you can clearly observe that the intensity of the colors, let me change the color. Okay, okay, so you can clearly observe that the intensity of the color or basic or intensity of the light is being easily visualized in this HSV image. Okay, so you can clearly see that this is a this okay, so here the light is more over this where it's pink, or I don't know which color it is. So it is a pink. Okay, and the colors of the this fruit are also visible. That which part of the fruit has higher intensity of colors. Okay, so this becomes an important task where we need to identify the lighting conditions of a room, or we need to distinguish between different intensities. That which color has a higher intensity, which color has a lower intensity. So to basically, let me again change the color to, so yeah, so HSV color space is associated completely with color and intensity information. Okay, so whenever we need to basically make a differentiation in intensity. Okay, so in this RGB image, you will be able to see that we can't make it any differentiation in terms of intensity, that where the light is more, where the light is less, which color is brighter, which color is not brighter, which color is dull, etc information. So you can't visualize those types of information in RGB image. Okay, but in HSV image you can easily visualize these types of information like color and intensity information. So this is why we use HSV color space. So we are done with color spaces. So as of now, just focus on these two, okay? RGB and HSV color image, color space. So Soumyadeep has a doubt, which color space is used in computer vision? In computer vision, every specific task is related to a different color space. For example, if you want to enable real-time object detection, okay, so you will be using this RGB color space, and whenever you need to deal with intensity of colors, of intensity of light and lighting conditions, about where when the image was clicked, what were the lighting conditions, when you need to deal with these kind of information related to color intensity and lighting conditions, we use HSV format or HSV color space. Okay. So this is how we convert an image to HSV color space. We simply take an image as an input. We pass the path and name of the image. Okay, so one more important thing to be noted down over here is that whenever whenever the script file where we are writing this OpenCV function, okay, so in whichever folder the script function or Jupyter notebook or Python script exists, if the image is in the same folder, you only need to specify the name of the name of the image. And when these things are in separate folder, or let's say that you have written this OpenCV script in a particular folder, and your image is stored in any other folder. Okay, so Python script can't access that image. Okay, so there you need to provide the path. Whenever the image in the Python script where the CV2 function is written, if those exist in different folders or different locations on a computer, then you need to specify the path of the image along with its name. If this Python script exists in the same folder and or in the same location as of the image, you don't need to specify the path, you just need to specify the name of the image. Okay, so we will be taking an image as an input, and this function CVT color, it will be converting image from BGR to gray. Okay, so this CVT color function is used to convert images from BGR to RGB or from BGR to grayscale. Okay, so we'll be taking the image as an input, and then we'll passing that image to this function CVT color. Okay, then we will be specifying that I want to convert this image into a grayscale image. Okay, so now this variable contains this image, but in grayscale format. Okay, and then you can basically plot it to see what are the results of this format, or what are the results of this code. Okay, so this is going to show you the grayscale image. Okay, now if you want to get an HSV image, what you need to do is you just basically need to convert this image, and you just need to specify that cv2.color underscore bgr to HSV. So what this function will do, this function will convert this image into HSV format. Okay, and then you can plot that image using plt.imshow. And don't worry about the codes, we'll be going through this whole code thing in Google Colab. Okay, so just check. Sujay has a doubt that in real-time application, where is HSV model is used, like edge detection or segmentation. In real-time application, it is used you can say everywhere where you want to know the color intensity or the intensity of the lighting, there HSV format is used. So let's now move to a different slide. So now let's come to image segmentation. Okay, so what is image segmentation? Okay, so just focus on this image. Okay, so you can see this is an image of a real-time person giving a pose, and now we want to basically uh, I just want now I want my computer vision model to tell me that where in the image human is present. Okay, where in the image this boy is present. Okay, so there are two types of segmentation. So one is this semantic segmentation, and second is instance segmentation. Okay, so in semantic segmentation we just segment the part we want to know. Okay, so this is the part, and I want my computer vision model to tell me that in which part of the image this human is present. Okay, so my model will return me this, and it will say that in this part of the image, the human is present. Okay, so we are not concerned about the surroundings. We are not concerned about any other thing. We are just concerned that in which part of the image human is present. Okay, so my computer vision model will say that in this part of the image, the human is present. Okay, a human is present. So this is another semantic segmentation. Now, in instance segmentation, you want to know that in which part of the image the human is present, as well as what it looks like. Okay. So to get this information, we use instance segmentation. So semantic segmentation, in semantic segmentation, we have this mask, and now we'll be putting this mask on this image. Okay, so I will copy this mask and paste it over this image, and I will get instance segmentation as a result. So instance segmentation model will basically provide me with the details that where the human is present and what he actually looks like. So this is the most basic difference between semantic segmentation. Semantic segmentation just tells me that in this portion of the image a human is present. It doesn't tell that how it looks like and what is the background of the image. But in instance segmentation, my computer vision model will be telling me that yes, this is basically a human and this is what he looks like and this is his background. So image segmentation is the task of classifying every pixel in the image to some class. Okay. So for example, I want to classify that which is in in an image, which part is a foreground and which part is a background. So again, I can use this information. Okay. So my segmentation model will return me that this is the foreground, and this basically this trees and all this are background. Okay, so this is what basically segmentation means. In segmentation, we classify every pixel of an image and just ask our model to return us the foreground and the background of an image. Okay, so this is the foreground and then this is the background. Okay, so this is one of the most basic examples of segmentation. And in other words, you can understand that segmentation basically means that extracting relevant part from an image. Okay, so in this image, the relevant part is this human, and we are asking a model to provide us with the extract the feature from this image, and that feature is basically relevant parts, and just tell me what are the relevant parts of an image. So a model will basically tell that yeah, this let me change the color. Yeah, that this guy is basically the feature of an image. Okay, so this is a relevant feature and other things can be ignored. So this is what segmentation actually means. So let's now skip to, we have a question from Sanya. She's saying that in segmentation, is segmentation the same as masking? Okay, yep, you can say that it's same as masking, but in segmentation we actually identify the region where we have to actually put the mask. So actually we create a mask that this is a human, and then we paste that mask on this person to get a segmentation image. So you can say that masking is a process of segmentation. And now let's come to edge detection part. So this is one of the most important application of OpenCV. So I worked with edge detection, and just trust me that every time I used edge detection, I was dealing with OpenCV. Okay. So basically, we all know about edges. Okay. So in this image, if I ask you that what are the actual edges of this image, so you can really easily able to tell me that. Okay, just let me change the color again. So these are the edges. Okay, so these are the actual edges of this, and then we have camera. Okay, so these are the edges. Now why we want to detect the edges? Okay, so basically edges are, we need to detect edges because edges are the points in an image where the image brightness changes sharply or has discontinuities. Okay, so when you will be becoming fluent with computer vision, I guess all are beginner level. Okay, so multiple times we will be having this issue of image brightness and discontinuities. So basically when we deal with edge detection, so edge provides us with the information that where the objects in the image actually are. Okay, so you can see that when we perform edge detection on this image, and it gave us this output, and by this output we can easily visualize that this is an image of a person. Okay, so basically, edges are very useful features of an image that can be used for different applications like classification of objects in the image and localization. So basically, what localization means. So whenever we are talking about localizations, we basically what we want to do is that we actually want these like I will ask my computer vision model to localize the photo of a photo of this man. Okay, so my model will be performing an edge detection, and it will be letting, it will give us two information. Okay, so the first information is that this is an image of a person. Okay, and second information, it will tell us that in which part of the image this person exists. Okay, so you can write it down that the first application of edges is whenever we detect edges, and we can use these edges to classify objects. Okay, so in this image this man is a an object, and we applied object detection, sorry, edge detection, and after applying edge detection we were able to visualize that yeah, this is an image of a person. And also this also gave me information that in which part of the image this man is present. Okay, so edge gave us two very useful information. First, first information was that what objects in are what basically uh, that what objects are present in an image and the location of those objects. Okay, so also you can focus on this camera. Okay, so I performed edge detection and it gave me these lines. Okay, it gave me that this is the edge of a tripod stand and this is the camera, and now I can basically easily visualize that this is a camera. Okay, this is the tripod stand, this all is the tripod stand, and the location of this tripod stand and the camera, that is this. So edge detection is a very useful information, and it helps us to classify the objects in an image, and it also helps us to localize an objects in an image. Okay, so basically what deep learning model does is that deep learning model basically calculate edge features using CNN layers. Okay, so we'll be coming to that part, don't worry. So CNN stands for convolutional neural networks, and whenever we apply this CNN to an image, it basically extract features from the image. Okay, so this is used for feature extraction. So these CNNs are used for feature extraction from images. Okay, So deep learning model basically calculate most of the time edge features and then use those edges to extract information about the objects present in an image. So now the second point, that we were able to easily, like at the first when you saw this image, and now if I tell you that this is an image of a person and this is the position of the person, okay, this is actually how neural networks perform in an image. Okay, so we looked at this image, and then we extracted. Basically what our mind did was, our mind basically detected the edges in reality. So this is how similar our brain and neural networks are. Our mind also detected using these edges only. Okay, so that's an interesting thing to note down over here. So let me just know the questions. Does it need to differentiate foreground and background, or the computer differentiates by itself? Yep, computer will differentiate by itself. Okay, so that's what image processing algorithm means, that we don't need to tell. And whenever we are providing an image as an input, so we don't need to actually tell that this is a foreground, this is a background. That's the question for the model basically. And by model I mean deep learning model or computer vision algorithms, different types of image processing algorithms. So this is the task of an algorithm, to identify the foreground and the background of the image. Okay, and so Priya has a question: is CNN an algorithm? Yes, CNN is an algorithm. CNN is a computer vision algorithm which extract features from an image using. Okay, so now any other questions related to edge detection? Just let me know in the comments if you have any questions related to edge detections, or any type of question. Just let me know in the comment. Okay, I will be just waiting for 1 or 2 minutes to just let everyone type their questions. Okay, so Amitdeep got it. Watch edge detection. And so we had that picture of a fruit, right? Just let me go back to that previous slide. Yep. So can anyone tell me that in this image, okay, so in this image, what are the edges? Okay, just let me know in the comments section. Okay, what are the edges used in this image? If I want to detect that this is an image of a fruit, then how will actual image detection algorithm work for this one? I'm waiting. Just let me know. Color. Okay. Shape features. Okay. We have different questions. Tanisha is saying that where there will be a change in the intensity. Nope. Then compare the brightness. Okay, so yeah, we have got an interesting solution from Tanisha and Tanishka. We can do this where there will be a change in the intensity. You can use intensity as well as compare the brightness, but that's going to be a hectic process. So if I combine both of yours solutions, so it is going to give me a really hectic one. Foreground and background color intensities. No. If I want to run edge detection on this, so my model will basically identify this circumference and this, and it will tell me that in this image the object is present over here. That basically means classification. and it's a fruit. That's classification. Okay, what is color intensity? So Raval has a question, what is color intensity? So color intensity is basically like in the left side RGB image, you can see that here is some white light. Okay, here is some white light, and here that white light is not there. Okay, so or is some is or in this left part the white light is only present over here. Okay, and in this right part the white light is present over this whole entire region. So that must be the cause of this color intensity difference must be the lighting conditions of the room. It must have been bulb at this end. So, oh, sorry, no, not that. It must have been due to the shadow of this. Okay, so you can basically create a conclusion from here. Okay, so if the part of an image contains light in excess part over here and doesn't contains light in these parts over here, so you can say that yeah, that can be due to the shadow and the right and the light is present on the right of the image. So that's something like you can just make a guess. Okay, so that's much complicated. So let's not go that much in the detail. You can clearly observe that this part contains white light in much abundance, and in this part only the white light is visible over here. I will share a slide. I will be sharing the slides with you all, and then you can clearly observe that the white light is completely visible over here, but in this part the white light is not in much abundant. So that's the difference between color intensities. Okay, and you can clearly observe then in HSV image that the white light region is this much on the left side and white light region on the right side is this much. So this is what we mean by lighting intensities. So Tanishka has a question, will it change to black and white first? Okay, so I know where you got that doubt from. Okay, so here you got that doubt, right? Tanishka, so you got that out from here. So no, this is like just split it out. Okay, I was just telling how to convert your image into a grayscale image. Okay, so this step isn't required. You can just do this step. Okay, so this is the first step, and this is the second step, and then to visualize the image, you can do this third step. This image is crossed out, so this will also get crossed out. Okay, so these are the steps to convert your colored image into HSV color space. Okay, so you can take this image as an input over here using imread function, and then you can use CVT color, that basically means color convert color, to convert the image into HSV, and then you can plot the image using PLT matplotlib library. Okay, so like before edge detection, converting to grayscale, will that be easier? Yes, in multiple scenarios color images contain very much information. So in few images where the intensity difference is not that much and we don't really care about the other features, okay, other features of the image, we can use black and white images for edge detection. But normally you can use edge detection on any image. Okay, so basically color images with higher resolution contain much features, so I would recommend that. And the task for you all today is basically to convert grayscale into HSV and then convert this color image to HSV. Also perform edge detection on both the images, that is grayscale and color images. Okay, and yesterday we had some questions like we had some question that can there be more color channels in an image greater than 3? So does anyone has an answer for that? Just type in the chat section. Okay, so no one has an answer. Okay, will we come to that in the later part? CMYK. Tharija has an answer. CMYK. Okay. So Tharida, can you write down the full form of CMYK so everyone can everyone can know that what CMYK basically stands for? Insania has the answer, the alpha channel. So basically you can increase and decrease the number of channels, but in like normally by default, color image contains only three channels that are red, green, blue, and for grayscale images it contains only one channel. Okay. So now how we detect edges with OpenCV? Okay. So the default step, importing NumPy, importing CV2, importing Matplotlib, and then you can use IamRead function to basically read the images, and then you just need to pass that image using in this function. Okay, so one of the algorithm to detect edges in an image is Canny edge algorithm. Okay, so Canny edge algorithm is pretty great algorithm for edge detection, but doesn't work well than deep learning algorithms. Okay, and the answer to that is that deep learning algorithm actually replicate the structure of your brain, so it becomes very easy to learn things for that algorithm. Okay, so you just need to take image as an input using IamRead, then provide in cv2.canny function. This is the image. So this is a first step. This is your second step, detecting the images, and this is your third step, plotting the edges. Okay. So now let's come to the most important part of the OpenCV. Okay. So the most important functionality of OpenCV is Cascade classifier. Okay. So these Cascade classifiers are also known as R cascades. So these cascade classifiers are also known as R cascades, and are basically machine learning classifiers that calculate different features like edges, line, etc. in the image. Okay, so I will later show you an example of how cascade files or how this R cascade looks like. As of now, just consider it as a file which enables edge lines detection. Okay, so this cascade classifier are files which OpenCV uses to calculate different features. Okay, and there are already these files are already available, so we don't need to build these files. Okay, so on GitHub repo of OpenCV, these files are already available, cascade classifier files, or basically R cascades as known in the world of OpenCV. So you can basically try different cascade classifier, and don't worry, we'll be going through this complete implementation of how we will be using this R cascade to detect faces. Okay, human faces. So basically cascade classifier uh, contains some functions. Okay, they contain some function, and on the right you can clearly observe that to detect edge features, it uses these types of filters. Okay, so these are the filters which are superimposed on an image, and then it calculate edge features. Okay, if you don't understand this, so don't worry at this point. Like this is a very simple concept. Okay, but it becomes complicated when any beginner will go through these. Okay, so don't worry about how it perform these edge features extraction, line feature extraction, and rectangle feature extraction. Just focus that cascade classifier is a file which is provided to OpenCV algorithm, and then that OpenCV algorithm will extract features from an image. Okay, and these cascade classifier are built using machine learning. Okay, so machine learning algorithms are used to build these cascade classifier, and these classifier calculate different features like edge and line. And I again just say that don't worry, and don't worry that how these things are calculated in using cascade classifier. Just focus that cascade classifier is a file which input which OpenCV takes as an input, and then that OpenCV function, which took these Cascade classifier files as an input, will perform feature extraction in the image. Okay, and these Cascade classifiers are available for different types of tasks. Okay, so first task is like basically human face detection and nose detection, eye detection, etc., etc. So these are all available on GitHub repo of OpenCV. So we don't actually need to build these classifiers. We'll be just using these classifier as an input to a model. So these classifier are nothing but a .xml file. Okay, and I'll be showing you an example how these Cascade classifier files look like. So let's now go to the slide. So to perform face detection using OpenCV, like this is one of the most common projects everyone does these days. As whenever anyone starts learning OpenCV, this is one of the most basic projects which they perform. Okay, so like how we actually perform face detection using OpenCV. So to basically use face detection using OpenCV, what we actually need to do is, our step one will be create, not creating, basically just eliminate the step. We'll be using a Cascade classifier. Okay, so our first task will be importing a Cascade classifier, and it will contain the feature of the faces. Okay, so as I told you that our Cascade is basically an XML file which basically extract features from an image. Okay, so we'll be using Cascade classifier for a human face. Okay, we'll be using a Cascade classifier for a human face to extract features. Okay, and then we'll be reading an unknown just let me give you an example that I will be reading this image using OpenCV, and then after performing, like I have already loaded this Cascade classifier, and now I have loaded the image using OpenCV. Now the third step is now the step is to basically extract face from this image using Cascade classifier. Okay, and then we'll be displaying a rectangle, this complete face in a rectangle box. Okay, so the first step is to import. Okay, so the first feature is to import face r. Just let me ease it for you. Cascade classifier. Okay, and then the second step is to load the image of the person, perform face detection using Cascade on loaded image, and then our fourth task will be basically to display a rectangle on the face. Okay, so yep, so these are the steps we are going to perform. First, we are going to import the face Cascade classifier, that is specifically Cascade classifier to extract features from the face. And then we'll be loading the image of the person. And then we'll be using this Cascade classifier in the third step to perform feature extraction and detect the face using this Cascade classifier. And then we'll be displaying a rectangle on that image. Okay. So just let me know if everyone got the concept of how, like everyone got the concept of how face detection is done using OpenCV, or does anyone have questions? Just type in the chat section. Okay. I'll be just waiting for one or two. After this, we'll be just skipping to the collab session. Okay, so Mary got it. So let's now just clear all the drawings and just skip to the collab session. So for first, you need to download an image. Okay. So, okay. So, okay. Just let me adjust my screen size. Okay, so let me download an image of a person. Okay. So person face image, just search and go on Google and okay, so I got this one or this one. Okay, so I'm going with this one. So I just need to save image as a person image dot jpg jpeg file. Okay, and I'm going to download another image, save image, and then save. Okay, and okay, so yep, you're good to go. So let me just upload my images in this collab session. So I have this dog and cat cover from yesterday, and I downloaded it person.jpg where that thing is. Okay, so where did I actually save that? Okay, I saved that in F volume. Whoa. Just lost the track of the image. No issues. I'll be just taking another video or the person. So this guy looks fine. So let me just update this image too. So I will just give you all a minute or two to just set up all your collabs, okay? So that we can go along with the session. So everyone is done, okay? Just let me know in the chat section. If everyone is done, we were just going through collab, okay? Just let me know in the chat section. Everyone is done or not. Okay, so very done. So I guess that we were good there. So let me just import numpy as np, import cv2, import matplotlib.pyplot as plt for plotting purpose. And now let me just create a case. So let me just So now it's good to volume, right? Okay, just it's fine. Okay, so let me now just read an image using cv2.imread, and I just need to provide the path of this image. So what I will do is I will provide path of this image, and just so now, yeah, the first difference between pillow and OpenCV. So when we use pillow, this image variable actually stored a complete image. But this time, when I will print this img, you can see that this contains the arrays. Got it? That this contains arrays. When I did same things for when I loaded images using pillow, it gave us an image object, right? Okay. So now I will use my cvt color function to basically convert my image, and I will be specifying that to which color space I want to convert. So that's BGR to RGB. So everyone had questions, right? How does BGR image looks like? The image format OpenCV basically opens, right? So everyone had this. So to solve this issue, I will be showing you how actually the default format in which OpenCV opens an image looks like. So now you can clearly observe that this is how our image looks when it opens in basically default format opened image, that is basically BGR, that is blue, green, and red. Okay, so this is the default image. This is the default format in which OpenCV opened our image, and that is BGR, blue, green, red. And now you can clearly observe that what's the difference between actual image and the default format in which our cv2.imread function has read this image. Okay, so now I'll be converting BGR to RGB. And to do that, what I need to do is I just need to do this. I will provide this. I will be providing this. I will be providing this image as an input to CVT color function, and the method I want to apply to this whole image. So I want to apply the convert color method, and that is basically I want to convert this image from blue, green, red to red, green, and blue. So let's now see using plt.amshow function that how our image actually looks like now. Okay, cv2 okay, cv2.cv. Oh, sorry. This would be in a small letter. Okay, I completely forgot that. Yes, now it should be fine. Okay, image. Okay, yeah. So our image is not defined. Basically, I use different format. So you all can now clearly observe that this is what red, green, and blue looks like. So whenever you see an image in this format, that is a real world image, it's always in red, green, and blue format. Okay, so keep this in mind. Now let's come to, so we are done with how we open an image, and now we'll be going through this, that how we actually convert an RGB image to an HSV image. Okay, and to do that we basically need to specify color underscore BGR to HSV in convert color function. Okay, so this is the best thing about OpenCV, that we don't need to write much codes to perform basic as well as complicated operations like changing the color space basically. So I need to take image as an input, and then I need to pass that image in convert color function, that is basically CVT color. And then I need to specify that yes, I want to convert that image from blue, green, and red to HSV or RGB to HSV, whichever the format you are using, you can use that. So as of now, I'll be using this default format for my images. Okay, cv2.imread. So I'll be using default format of OpenCV now. Okay, so okay, so let me just again pass the images because I don't want to. Yeah. Oh, sorry. Changing color space to HSV. Okay, nice. So let us now load the image. Now what I need to do is that I basically need to use CVT color function, and what I need to do now is that I need to provide this image variable input to this CVT function. Okay, img, and now I need to specify that how. Yeah, now I want to specify that from which format to which format I need to convert this image. Okay, so here we converted B blue green red, the default format of OpenCV to RGB. Now here we'll be converting it to blue green and red to HSV, and let's okay. So now let's see the results now, that how our image actually looks like. So this is how it looks like. So you can clearly observe that in this image, we can't tell the difference between different color intensities and different lighting conditions of this image. But when I converted this image into HSV format, that is basically hue saturation value format, I am able to clearly visualize that the lighting condition of this images are that on the ears and neck, on the top, and as well as eyes, the light intensity is greater than other parts of the body. Okay, and same for the cat too. So this is what HSV is used for. HSV is used for analyzing light and intensity related works. Okay, light, color, intensity, light intensity, etc., etc. So whenever it's about dealing with intensities, we convert images into HSV format. So we are done with this, and now let's come to image segmentation. How we perform image segmentation using OpenCV. Okay, so I'm just giving you a minute to just let me know that has everyone done till here. Yep, so everybody is done. Okay. Okay, so now it's time for some really interesting work, and that it's going to be our edge detection. Okay, so how we perform edge detection, and don't worry about segmentation part. Okay, so I will be coming to that too. Okay, so edge detection, basically now what we need to do is, let's take image as an input. Okay, or let me take a new image as an input. So this is the image of a man or a girl, I don't remember now. So let me just pass in the path and let's check how our image is looking right now. Okay, so plt dot I'm sure, and I need to provide this as image, and let's see how our image is looking like. So this is how our image looks like. It looks like somewhere from Avatar movie, right? With all the blue face and neck. So now if I want to perform edge detection, so one of the most important, or one of the most famously used algorithm for edge detection is Canny edge detection algorithm. Okay, so I won't be going into that much detail as of now because that is complete, that edge detection is a completely different topic. Okay, it's a very vast topic, and different types of edge detection algorithms are available in the market as well as in research, and they are very mathematically extensive. Okay, so this is a vast field, and this is a completely different field, the field of edge detection. So now if I want to detect the edges, okay, so I will specify in a variable edges over here, and now what I will do is that I will use Canny edge detection algorithm, and I will pass in my image. Okay, so you just let me write it down somewhere for you all to understand later. Canny edge detection algorithm for edge detection. Okay, so now let's see that what happens over here. Okay, Canny is missing. Okay. So I need to specify x and y too. Yep, I need to specify. So let my x be 100 and x be 2y. It can be any value according to your use case. So just you can play around with these values 100 and 200. Okay. Now let me show you how this edge detection algorithm worked and what are the edges it identified. Okay. So you can clearly identify that this is an image of a man. Okay, this is an image of a boy wearing spectacles, and our object detection algorithm gave us all the edges of the this human. Okay, and using these edges we can clearly identify that this is an image of a boy wearing spectacles, and these are his hair, and also we know that in this part of the image the boy is present. Okay, so let me just take a better example, like we can use this. Okay, so let me just take an example of a real world image. Like there are very different types. Okay, so that's what shit. Yep, so let me just yep, mount edge detection will work very well for mountains. Okay, so let me just download an image related to mountains. Okay. Yep, so this is a, yep, I got this image. Okay, so I'm saving this image and I'm saving it downloads Swiss apps, and just let me go back and upload that image Swiss apps. Okay, so now I want to basically perform edge detection on this Swiss apps image. Okay, so what I will do is that I will create a variable Swiss, and I will use cv2 dot imRead function, and I will be passing the path of this image over here. Okay, so now I'll be using Canny edge detection algorithm to detect edges. cv2 dot Canny, and I need to pass the name of my image, and for now it's Swiss because we want to perform edge detection on Swiss apps, and after performing Swiss, writing on Swiss, let me just tell it about some x and y coordinates. So let me now show you that how this looks like. Okay, sorry, I printed the original image. Swiss edges. Yep, so you can clearly see, but this contains a lots of edges. Okay, so this is one of the drawbacks of the image. If our image contains too much information, and like literally very much objects are present in an image, so our edge detection algorithm will go through all the edges and it will just return us this. So this is a like so this is where edge detection basically fails. Okay, so although the edge detection algorithm is basically able to identify that these are the mountains and these are the houses, but it has failed over here. So I won't say fail, but our human eyes aren't able to distinguish between different edges over here. Okay, So now let's come to face detection using OpenCV. Okay. So everyone has this issue that what is the use of X and Y coordinate? Okay, so let me just show you that how this variable changes. Okay, so let me perform on this image. Okay, so if I perform 20, 20, okay, so just stay with me. Okay, so this is used to control the threshold values, basically you can say, of the images. Okay, so if I specify to a very high value like 200, like let me just specify to 500 comma 1000, and now let's just visualize the inputs. Okay, okay, so this is basically, you can say, a thresholding condition, and this is a different values for different images, and it's just some values which you use according to your use case when you want to detect edges at a very large scale, or you want to detect edges at a very low scale. Okay, so for the best you can, so best here works is 100 comma 200, and similarly for the swill salves. Okay, so for the Swiss Alps, this value is very high because we are getting too much edges. Okay, so let me just reduce this to 30 comma 30. And let me just, so yeah, you can see that still it's not working as we thought it to work. Okay, so these are some values which you need to play out and check that which is performing best according to your use case. So as you increase or decrease these values, you will get different edges on the image. Okay, so according to your use case or according to your problem, you need to adjust these values for edge detection. Okay, and nowadays OpenCV is used for edge detection, but like these are also being some, there are some deep learning algorithms that are also being used, but that are very computationally expensive, and deep learning algorithms are very, like if you want to run it in real time, they are very slow. Okay, so yep, so you can see that when I shifted this uh, these two values 300 comma 300, so now we are, our humanizer is able to basically distinguish between houses and trees, and these are the mountains. Okay, so you need to adjust these two values, and according to your use case you need to check these values out and see which of them perform best for your use case. Okay, so should I start with face detection part? Just let me know in the chat section. Okay, yes. So let me import CV2 again. So this is just like I want to do a fresh start for page detection. If you have already imported CV2, that's not an issue. You can just load it. Okay. Now what I need to do is that we just talked about 4 steps. Okay. Loading the Cascade classifier for face detection. Okay. Loading the image, using Cascade classifier to detect face in the image, and fourth option is display the image with a rectangle Euler box on the face. Okay. So these are the 4 steps of face detection using OpenCV. Okay. So for the first step, that is the first step is loading the Cascade classifier for face detection. Okay, guys. So first of all, we need to create a file Cascade classifier for face detection. Okay, so this is an XML file, and let me just show you an example how Cascade classifier looks like. OpenCV Cascade GitHub. Okay, so these are our details are all stored on these OpenCV, this GitHub repository. Okay, so you don't need to actually write it down again and again. So if I want, so you can clearly observe that these Cascade classifiers are available on internet. Okay, for they are basically for eye, it's available eye for eye detection, for frontal face, for frontal cat face basically. Okay, so to detect cat faces, this Cascade file is available for frontal face, another version of you detecting frontal face and full body, left eye, license plate on cars, etc., etc. So what I will do is I will just use this front face Cascade. Okay, so this is an XML file. Okay, and it is obtained using you can say machine learning classifiers. Okay, so this is how this file actually looks like. Okay, so here we have defined height and width, and there are some threshold values, and then there are leaf values, internal nodes. You don't need to know about these things. Okay, so because we are just going to import this file and use it with our OpenCV. I'm just showing you as an example that how Cascade files looks like, and how Cascade files are basically XML file. XML stands up for extended markup language. Don't worry about it. Okay. So yeah, so these are the files we are actually going to use. Okay. So whenever I click this, go to file, and okay. So just let me just share the link of this GitHub repository with you all. Okay. So you all can do the same things, or just let me share the whole Cascade files file I created. Okay. So I just clicked over here. Oh, okay. So let me just also share this GitHub link. Okay. GitHub OpenCV Cascade. Okay. So I'm putting it in the chat section. Okay. So here's the chat section, and I have put up the link of Cascade classifier. And meanwhile, you all can just go to this GitHub repository and perform the same operations as I'm going to do. Okay. So everyone has opened the GitHub repository, right? So just let me know in the chat section. Okay. So when you will open that link, you will be getting this web page, and on this web page, you will be getting this icon on top right of the file. Okay. So when I click this icon, it basically means copy raw content, and just left click on this. So actually I've copied all the contents, and now come back to collab. Okay. So now right click, new file, and face classifier, or let me just name it to face cascade classifier. Okay, and just double click on this file and just go to where and just paste the contents. So this is your Cascade file. Okay, so this is a Cascade classifier. And then go back to this file and just rename it and just add .xml at the end. Okay, so don't worry, I'm also downloading this file to share with you all. Okay, so I downloaded it file. I am just uploading it to my this face Cascade classifier to my drive, and from drive I'm sharing it with you all. Okay, so you all can download this file and then so in the chat section, I put up the link for a Cascade file. You can just download that Cascade XML file and just go to collab, click on this and upload this face Cascade classifier. Okay. So now let's come back to collab. Okay. So when I go back to collab, what I need to do is I just need to load that Cascade file. Okay. And to do that, what I will do is basically I will do cv2.cascade classifier and I will copy this file, copy path, paste it over here and done. So the Cascade file is loaded and you can check it out what variable contains. Okay. So this gave us this Cascade classifier at this. So this basically means that the Cascade file is basically loaded and we have been returned that Cascade classifier objects exist at this location. So let me just delete it. And now the second step is basically to load the image. Okay. And to load the image, what I will doing is that I will be getting a variable person and cv2.imread and I need to pass in the I think yep this image of a man. Okay. Okay, so I've loaded the image of the person and let me just visualize the image of the person, how it looks like using plt.imshow and passing this variable over here. So this is our person looks like, same avatar guy. Now what we will do is I will be converting this image to a grayscale image. Okay, so to do this I will be using cvt color function which we used earlier, and then I will be providing the image as an input and I will be telling cvt2 to basically convert this image from cv2 using 2. Okay, okay, yep, so this one. Okay, so I just told cvt2 to convert this image to a gray image. Okay, I will be converting this bgr since this is the default format in which OpenCV open images, blue, green and red, and I have used the cvt2.cvt convert color function to convert this image into a grayscale image. And let's now again visualize that how this image actually looks like. So this is now how our image is looking like basically. So this is the grayscale version of this image. Don't worry about it. Grayscale actually doesn't means that everything will be in gray. Okay. Black and white actually means that everything will be in black and white. So this is the most significant difference between grayscale and black and white. Black and white basically means that the actual image will be in black and white, but grayscale basically means that your every color axis has been converted to a grayscale value, and that's a different concept. So just not to confuse you. Okay. So now I want to perform this face detection. Okay. So what I will do is from face I'll be calling that Cascade classifier. Okay, phase cascade basically means that this thing. Okay, so I loaded my Cascade classifier into this variable, and now I'll be using that variable. Okay, so that variable dot detect. Okay, multi-scale, and I want, so what this basically is, this detect multi-scale function is telling us that I want to detect face in this image. Okay, so by chance if you have loaded eye cascade files, okay, so you wanted to detect eyes in these images. Okay, so what you have done is you have then basically loaded eye cascade function, and then you have defined eye cascade dot detect multi-scale and then pass in the images. Okay, and now there are some additional hyperparameters which you can play around and just so I'm giving this function these two variables, the hyperparameters. You can also play around with them. Okay, play around with them to see that which performs best for use case. I'm using 1.1 comma 4 because these works with maximum face detection task. Okay, now we have loaded the image. We have, so this was the step to basically detect the face using Cascade classifier. Okay, so now we have performed face detection, but still, like, you just know that in this variable face those values are stored. Okay, so just let's visualize at what this face variable contains. Okay, so this contains nothing as of now. Why this contains nothing as of now? Face can just say detect. Okay, so let me just move ahead with a different image. Let me just go ahead with it and let's check what's the actual problem. Okay, so forget about it. Okay, so now what we need to do is that I basically need to draw a rectangle around the face. Okay, drawing a rectangle around the face. So now what I am going to do is I will be using for comma y comma w comma h in faces. Okay, but a faces doesn't contain anything, so that must be the problem of XML file. Okay, so it looks fine, right? Like, I have loaded this face cascade classifier.xml over here. So let me just check that whether this is performing or not. Okay, so don't worry, just wait a minute. I'm just checking out my Cascade file, like whether my Cascade file was appropriate or not. So let's just give me a minute, guys. I think there's some problem with Cascade file. Okay, so I'm just checking it out that where the error actually is. The Cascade file is actually looking fine. Okay. So let me just change my this person image. Okay, let me just select this one. Okay, and instead of that, I'm going to use this one. Yep. So let me just rerun the cells again. Yep. So that was the problem with the image. Okay, so don't worry, guys. Okay. So yep. So we used face underscore cascade, and that's basically the loaded cascade file. Okay. So that's the same as this one. So this was the variable we used to load a cascade classifier file using cascade classifier, and then we provided the path of the XML file which created over here. Okay. So now basically phase gave us four coordinates: 111, 176, 275, and 275. So basically what these values are nothing but the coordinates of the rectangle. Okay. So let me just write it down. Coordinate of the rectangles are stored in faces. Okay, so coordinates of the rectangle are stored in the faces. Okay, so this is x, this is y, this is width, and this is height. Okay, now I want to draw basically a rectangle. Okay, so what I will do is I will extract these values using for function, and for that I have written x, y, w, h in faces. And now what I will do is I will call cv2 dot rectangle function that is going to draw a rectangle around our image. And let me just import the original image. Okay, so the name of the image was okay, person. Okay, so the name of the image was person. Okay, so let me just give you this person, and now I need to provide the x and the y coordinates. Okay, so x and y coordinates, and then I need to provide the other two coordinates, and that would be x plus w and y plus h. Okay, and now I need to provide that what would be the color of my rectangle. Okay, so the color of my rectangle will be given in RGB values or BGR values, since OpenCV works with BGR values. So this is blue, this is green. I am drawing a rectangle around the face of the person whose coordinates are this x, y, w, and h. Okay, and then I need to start with these point x and y, and these are the other two coordinates of my rectangle. Okay, now what I will do is I will do cv2 dot I'm show, and I will show the image of the person as well as, okay, and now I need to write cv2 dot weight key. Okay, so basically these weight key is used when we are writing scripts. Okay, so when we are writing scripts, this is used, and it basically means that the image of the person, the output will be displayed until unless the any different keys isn't pressed. Okay. So you can see that oh, I didn't converted this image into original. Okay, so let me just convert the person. So this is the image of the person in blue green net, and let me just give you color. Okay, so color is and I cv2 dot cvt color, and here is the person, and I need to convert the color of the image cv2 dot color and from bgr to rgb, and here I just need to pass the color. Okay, so you can clearly observe that here this our algorithm, that is OpenCV Cascade classifier, perfectly detected the face. Okay, so face is enclosed in this blue line. Okay, so you will be able to observe completely this blue line. Okay, so this was all for the day, guys. So let me know if you have any issues or any doubts in the comment section. I will share the link and as well as the PPT. Okay, so let's just skip to the chat section. Okay, so Adire said I did the same thing and I'm getting an array. So I don't know where the actual problem was, because also like I did nothing. I just changed the image of the person and it also gave me this array of faces X, Y, W, and H. So just let me know if you have any problems, or I'm waiting for a minute or two. Okay, so no issues. Great. Okay, thank you guys. So tomorrow we'll be learning about object detection, YOLO algorithm, and how we use YOLO algorithms to basically detect images. Okay, so goodbye, good evening, and thank you for attending the session.